You ever get the feeling that numbers are hiding something? That behind just counting things, there's this whole secret world of patterns and rules just waiting to be found? Well, you're not wrong. And today, we're going to crack that code together.
All right, let's kick things off with a little challenge. Take a look at this sequence. What number do you think comes next? I'll give you a second. It seems pretty simple, right? But this is actually the first step to unlocking a much, much bigger idea.
And that's really what this is all about. We're going way beyond just counting. Numbers have their own language, you know? They form these patterns and sequences that have a real structure, kind of like a grammar. And once you learn to see it, you start finding it absolutely everywhere.
So this secret language, well, it actually has a name. It's a whole field of study in mathematics, and it's called number theory. And it's all about finding the poetry in the patterns.
And look, this isn't just about solving puzzles for fun. This is a fundamental part of how we understand the mathematical universe. The study of these incredible patterns and whole numbers is exactly what we're diving into today.
Okay, I know what you might be thinking. Number theory, that sounds super complicated. But I promise you already know the basics. We're going to start with patterns you probably know in your entire life.
Let's start with the most basic pattern of all, just counting numbers. I mean, it's the first sequence we ever learn, right? It's so simple we barely even think of it as a pattern, but it absolutely is.
It has a really clear, predictable rule. So what is it? What are the next three numbers that should pop up here?
Yep, you got it. The rule is just add 1, which of course gives us 8, 9, and 10. It's simple, it's elegant, and it's perfectly predictable. That's the heart of a pattern.
Okay, let's build on that. Here we have the odd numbers. Hey, this is the sequence from the very beginning of our explainer. Just by looking at it, you can probably already feel the pattern.
But let's get specific. What's the actual rule that's making this sequence happen? What are we doing each time to get from, say, 3 to 5 or from 9 to 11?
That's it. You just add 2 every single time. And by using that rule, we can predict this thing forever. The next 3 numbers are going to be 15, 17, and 19. See, you're already speaking the language.
All right, so adding is cool and all, but what happens when these patterns start taking shape? This is where number theory gets really visual, and honestly, I think it gets really beautiful.
Check these out. 1, 4, 9, 16. They're called square numbers for a pretty awesome reason. You can literally arrange that many dots into a perfect square. 1 dot is a 1 by 1 square. 4 dots make a 2 by 2 square. 9 dots make a 3 by 3 square. You get the idea.
And we can totally kick this up a notch into the third dimension. So if a square is a number multiplied by itself, a cube is just that same number multiplied by itself twice. We're going from a flat 2D shape to a 3D one just by adding one more multiplication. It's so cool.
And this is the real power of finding the rule, right? Once you know it's n times n for squares, finding the next 3 is easy. 49, 64, and 81. And it's the same for cubes. We just keep multiplying to get 343, 512, and 729.
Okay, now for the part that feels, well, kind of like magic. We've seen patterns based on adding and multiplying, but some sequences are built on rules that are way more surprising.
This sequence right here, it's one of the most famous in all of mathematics. You might know it as the Fibonacci sequence. The source material calls it Hiraynikara's numbers. Just look at it for a second. The rule here, it's not so obvious, is it?
But here's how it works, and it's actually super simple when you see it. You start with 2 ones. Then, to get the next number, you just add the 2 that came before it. So 1 plus 1 gives you 2. Now you add 1 and 2 to get 3. Then 2 plus 3 gets you 5. It's like a feedback loop, a pattern that literally builds on itself.
And once you have that rule down, you can just keep going forever. So to get the number after 21, we just add 13 and 21, that's 34. Then 21 plus 34 gives us 55, and 34 plus 55 gives us 89. It's so simple, but it's incredibly powerful.
Okay, last up, let's look at patterns that are all about growth. With powers of 2, you just double the number each time. For powers of 3, you triple it. This is what's called exponential growth, and you can see just how fast these numbers get absolutely huge. The rule is just repeated multiplication. So think about it. In just the last couple of minutes, we've gone from a simple little puzzle to understanding some really fundamental, beautiful patterns in math. You've basically been given a new toolkit to see the world a little differently. So let's recap.
Here's your brand new pattern finding toolkit, all in one place. We've got rules for adding a constant number, for multiplying a number by itself, for adding the previous two numbers together, and for multiplying by a constant number. Think of it like your new decoder ring for the language of numbers.
And that's really the best way to think about it. You haven't just memorized some numbers, you've learned the grammar. You now have this new ability to look at a string of numbers and ask, okay, what's the rule here? What's the story this pattern is trying to tell me?
And that brings us to the big question at the end of all this. We've cracked a few codes today, sure, but the universe is absolutely full of them, and nature and music and technology everywhere. So now that you know what to look for, what patterns are you going to start seeing?